we're going to evaluate cosine, the arc cosine, at -1/2. And we're going to do that, so let it equal theta, because we want an angle as an output. We want to do that over its natural range. So the natural range for cosine is quadrants 1 and quadrants 2. So the output values, the natural range is between 0 and pi. That's always the case for cosine. Sine and tangent are between -pi/2 and pi/2. So when I ask for what is the cosine value of -1/2, what that allows me, or what that gives me here, is I need a left distance. So this guy is -1/2. So my angle is right here. That's our theta. Draw that a little bit better so you can see it, that it's an actual theta. Just like that. So what angle has a left run movement of -1/2? Well, that's going to be 2 pi over 3, or 120 degrees. So our theta value is going to be 120 degrees, or 2 pi over 3. Now we can check that immediately with our calculator, because our calculator will give us the same values out, because it's going to give us over the natural range. So we'll go our cosine of -1/2, and we're getting our 120 degrees. For example number 7, I'll do them both here at the same time. They want the arctangent of 1. So again, we can draw out our picture. Write down arctangent of 1. Now remember, arctangent of 1 is the same as writing this. Okay, so these guys meet each other. So in words, what this says is find an angle Now remember, we're working in the natural range, whose tangent value is 1. So the natural range for tangent, or arctangent here, the outputs are going to be between -pi/2 and pi/2, or -90 degrees to 90 degrees. So our angle is 45 degrees, because that guy has a tangent value, has a slope of 1, and that is pi/4. So our solution for theta here is 45 degrees, or pi/4. If we grab our calculator and we check that guy out, the arctangent of 1 is 45 degrees.